to be doing some more specific types. Okay, now I'm hoping what I would see on your study sheet that when it says this is what you should do. But if it's saying at least, then do it this way. If it's saying exactly, then do it this way. Okay? When it's saying at most, do it this way. When two vowels have to be together, do it this way. When two things cannot be together, do it this way. Because I think in parts, you guys are showing great understanding. What happens if I take all the parts together? Well, you shouldn't be, let's say it, but you should be able to go, oh, it's this type of question. I'm going to do this. If you're not at that stage before the unit exam, you will do quite poorly on it. Probably fail it. You should be able to look at every question and go, that's this type, that's this type. I find that this book does an excellent job of putting things into compartments. You have to as well, okay? And that's the whole reason for the study sheet. Can you see the 10 different types all at one time and see why this would be this, okay? And hopefully you're coming up with questions and going, like, how could you make this one a combination, okay? I know it's a permutation, but what would the wording change, okay? So let's work with the words at least, at most, and some other things we're going to be doing today. Now, when we do A, we should all know how to do that. There's a student council decides to form a subcommittee of 5 council members to look at how funds are raised. Right now, there's 11 council members. 5 are male and 6 are female. So how would I find exactly 3 females? 6. Okay, so I'm looking for 3 females, and what's implied here? 2 males. Okay, so that would be 6 choose 3 and 5 choose 2. Good. And that's 200. These should take longer to put in your calculator than they take to actually write down. But this is the important part. If I was doing multiple choice, I'd probably just put that in my multiple choice. I wouldn't put the 200. Once in a while, they'll put the numerical answer, but most times that's what they're concerned, or I'm concerned with. You know how to do that. Now, the wording can be changed a little bit, and I want at least 3 females. Now, how can we put this in layman's term? How would you talk to a 5-year-old and tell them, what does at least 3 females mean? You could have 3 females, you could have 4 females, you could have 5 females, you could have 6 females. Could you have 6 females, 7 females? Why not? Because there's only 5 of the committee. Okay? So, guys, are we okay back there? If I would have 3 females, 2 males. Now, would it be or and? Or 4 females, 1 male. Or 5 females. This is what at least 3 females means. And it would be or, because I don't want 3 females, 2 males, and 4. It's or, okay? The subcommittee will not contain 3, 4, and 5. It will be 3 or 4 or 5. Okay? Now, the 3 females, 2 males, well, that should be what we had here, 6C3, 5C2. Okay, or it's the plus sign. And we will go 6C4, 5C1. Or 6C5. Now you could put 5C0. How many ways can you pick nobody? It's actually one way. Okay, that is a possibility, right? That's one way to pick nobody. Okay, but where does this put 65? Okay, and then when you do that, 281. And that's a little bit of an adventure putting that into your calculator, but that's the easiest way to do it, sort of. Okay, now at least one female. Okay, now at least one female, you have two options to be able to do this one. And again, something you want to put down on a study sheet. Because if I use every position for females, so I am using 1, 2, 3, 4, or 5, right? That's how many I can have. I can have 1 female, 4 males, or 2 female, 3 males, or all of this, right? 3 females, 4 females, 5 females. So this would be 6C1, 5C4, plus 6C2, 5C3, plus 281, right? I already figured out the rest, so I do it again. Okay, and you'll get the answer 461. Now, when you have at least one, not at least 2, not at least 3, but when you have at least one, you can also use the complement. Okay? And this is part of the curriculum, so you have to know how to use the complement for my test and the diploma. How could you write this? Now, the complement will always be no restrictions minus, the complement is the opposite of at least one female. What is the complete opposite of at least one female? No females, right? No restrictions. Okay, if I just said, here's all the people, pick me a subcommittee of 5. What's no restrictions? 11, choose 5. Minus, that's the same thing as no females. All males. Which is 5, choose 5. And you, of course, will get 461. Okay. Now, at least one red card. Now, as soon as you see at least one, that's when you can use the complement. Not for at least 2, 3, 4. At least one is the only time you can use the complement. Okay? So, it's always no restrictions minus the opposite of at least one. Okay? So, no restrictions. We're going to use the complement here because it's way faster. Minus number of black cards, right? Or no red cards, whatever you want. Again, I told you that this is one of those tests that you're going to be really concentrating, like every word, every little thing, the ors, the ands, the, okay, at least one is at least two, at most, okay, all those words. But if you get good at these, oh, it's an at least, I'm going to do this, okay? That's where you need to be with your study sheet. And if you're with that way with your study sheet, you will do extremely well. Okay, we're probably going to get something, I don't know if it's going to be as drastic as the last average, but it's going to be a good one. Okay? The thing that really changed the class average was that I didn't have many people bringing the average down. Okay? The thing that will be different on this, there will be a few people that they just won't know all those little things, and it's going to be a tough test, right? If you don't know all these little things. So what is no restrictions? 52, choose 5. That is the most hands I will possibly get. What is the number of black cards? 26, choose 5. And that's 2,533,180. Okay, so can I come back up to here? I didn't write this down, but whenever you see at least, you want to add them up. Okay. Now, I didn't do that for A, but I could have. I could have done 1 red card, 4 black, 2 red card, 3 black, 3, 2, 4, 1, 5, 0. I could have done all that. And I would be honest with you, if it was me, I would do that way on a big test. If I came back, I would do the complement. Now, it's different, obviously, if the multiple choice is, how could this be written? And the only one they have is 52C5 minus 26C, okay? So, of course, I'm going to pick that one. They didn't have the 1 plus, right? So I do have to know that these are the same thing. Now, at most, 2 kings. Now, again, articulate this in 5-year-old terms. What does at most mean? No more than 2? Even be simpler. A 5-year-old would still 0, 1, or 2. You can have 0 kings, because that's the one that most people would miss. So you could now, this will stand for king. This will stand for not king. Okay? A K with a line over it means not a king. So I'm doing 0 kings, 5 not kings, or non-kings, or 1 king, 4 not kings, or 2 kings, 3 not kings. Okay, so you're seeing the difference between at least and at most. Okay, so I can have 0 kings, 1 king, or 2 kings. So, how would I pick 0 kings? Four, choose 0. Good. And 5 kings? 5 not kings, I should say. Good. 48, choose 5. So I could do that possibility. Or I could do 1 king, which is 4, choose 1. 48, choose 4. Or I could do 4 kings, or 2 kings. 4, choose 2. And 3 non-kings would be 48, choose 3. Okay? Now, a test could have dots in between these, right? Meaning multiplication. Or simply we'll put them in brackets to mean that. Okay, so it can be dots or it can be brackets in between. Okay, now this one is a nightmare to put into your calculator, but it's the only way you're going to get this one done. but you'll get 2,594,400. Remember I told you could go 3 right or you can go 1 left? You'll see the 1 left does actually come in handy when you have to put 1, 2, 3, 4, 5, 6 of these in. Okay? So now this one is a little different, okay? So we've got at least at most, this says exactly 2 pairs. Now, again, I would be very surprised if anybody could get this one. But after we do it, I'm hoping everybody gets this one. Okay, because this has a little quirk in it that you have to kind of do at the end. Yep. Well, you wouldn't ever get colors, right? Because you can't get 2 queen. Oh, I see. Yeah, no, that they would say in same color. Okay. So we are looking for pair of queens, pair of tens, pair of 4s, and pair of 6s. Okay, so what am I looking for, first of all? Like, let's write something so we at least get the 5 cards. Okay, so I am looking for a first pair. I'm looking for a second pair. And what's left? So, another card. So it cannot be what the first pair or second pair is, or that would not be exactly 2 pairs. Now, how would I pick a pair of 4s? 4 choose 2. How would I pick a pair of 10s? 4 choose 2. How would I pick something that is not those first 2? How much? 44 choose 1. Does everybody see this? Okay. Something has not been accounted for, though. Is it 4s? Is it 10s? Is it 7s and 3s? Is it jacks and queens? Okay. So that's where this last part comes. We haven't done that yet. It would be there are 13 types of cards, and we're choosing 2 of them. Okay? Now again, you're going, oh, how would I have known that, right? Well, now you do know that. So whenever you're doing, so this deals with, there's 13 types of cards, and I'm picking 2 types of them. So this would be, like, I do take a lot of time teaching you guys that 20% of the diploma, that, or my test, right? Because the diploma wants to know that if you're getting over 80, you know your stuff. Yep. Not suits. There are aces. There are queens, kings. So types of card. I would have put suits if I, or colors or whatever. But there's 13, like as in queens, aces, threes. That's what I mean by that. Okay? It's a good question. Okay, so if you ever get something like this, you know how to do it. Unless, of course, you don't put this one on your study sheet, right? These are all 3 different types, and if you don't know every type, now, here's something else that is very unique about combinations. If you see all these toys, okay, And if you ask me to pick a group of 2 out of these 10, what am I left with? A group of 8. So every time I pick a group of 2, I am left with a group of 8. So the amount of groups of 2s always equals the amount of groups of 8. Okay? So that's why 10C2 equals 10C8. See, with permutations, if I had to take those 8 toys and make unique groups, there's a lot. But do you know, in that group of 8, I can't make another group of 8 with those same in it that's different. Okay? Well, if that was a permutation, see that group of 8? I could make many, many, many different groups of 8 if it was a permutation. But if I gave you those 8 toys, and I say, make me a different group, you'd probably change the order and go, there it is. No, that's the same group, because it's a combination. Well, I don't care about the order. Look, if I was to put them all in my arms and carry them away, it's the same no matter how you do that. But if I said I want you to take pictures where no 2 pictures are the same, well, you'd switch those 2, and you switch those 2, and there's tons of them. But there's only one group of 8 when I take a group of 2. So what is unique about combinations is if you have 10 things, every time I take this group of 2, I am left with that group of 8. Okay? If I take another 2, then I'm left with an 8. So every time you take a group of 2, or every time you take a group of 3, there's a group of 7 left over. And that group of 7 is, it doesn't matter how you turn it around, you're never going to get a different group with those 7 things. Okay? So that's one thing you have to always know about the difference between permutations and combinations. Permutations is like if I bought one of those, so I'm talking, if I had to buy one of these, I'm only allowed to buy one of them, and I only have enough to buy because my allowance comes every week, I can only buy one every week. Do you see how that would be a permutation? But if I had enough money to buy all these 8 at one time, would I buy them any differently the first week than the second week? No, I wouldn't, right? Or if I bought these 2, I'm left with how many groups left? Just one group, right? And if I took this group, I would just still be leaving one group. Okay? So when you see 10C2 equals 10C8, if these 2 numbers here ever equal this, then these 2 are equal. Because every time I take a group of 2 from the 10, remember, this is how many groups, right? There's only one group that would be one group for this. Okay? So give some other examples. 7C3 would equal what? 7C4. Okay, and 11C2 would equal 11C9. Good. So the general way to write this is NCR is the same thing as NCN minus R. Okay, and it says algebraically. Now, just so you know that NCR, oops, this is another way to write it. You can also write it this, N over R in brackets. Okay, that means a combination. N over R equals the same thing as N over N minus R. Okay? Now it says algebraically show this, and I'm not going to do this. Now, the next type of question, this is another type. This is a handshake question, okay? I would literally call this a handshake question because there's something you always need to know when you do a handshake question. They are unique. During a Pee Wee hockey tryout, all the players, so we got a tryout. All the players met on the ice after the last practice and shook hands with each other. How? Now, algebraically determine the number of players who attended the tryouts if there was 300 handshakes in all. Now, is this a permutation? No. Okay. So the answer is 300. Okay. NCR, oops, NCR equals 300. Now, I cannot find both of those. I need to know one of them. There's something highly implied here, you guys. You shook hands with everybody. How many people were there? That's what I'm looking for. What am I looking for? Does anyone know which variable I'm looking for? N. That means by reading that question, you should know, oh, that's what R is. R is 2. Why? Can you guys give me a demo? Can I get a demo? Yeah, 3 people, that would look weird, right? So, whenever you see a handshake question, now that took a long time. It was silent for probably 2 minutes, and one group figured it out. So do you see how, and the same thing happened in the last unit, like you guys didn't know the stuff, obviously. We went through it, and it was easy. Same thing with this one. If I get you on a handshake question now, like you can't do a handshake question, A, you didn't show up for class, or B, didn't put it on your study sheet and you forgot it. Okay? So I would write down, okay, we've got an at least question, an at most question. Remember that NCR equals NC. Also, handshake questions. Remember, R is 2. Have a little example down, okay? So we've got NC2 equals 300. Okay? Now I'm just looking for N. Now, how do you find N? Multiple choice, guess, and test. Absolutely. I'd be thinking it's a hockey tournament, or it's a hockey tryout. Maybe think bigger numbers. You can also put this into Y1 of your calculator and go to table. But this one, we're going to do algebraically because it's a written response question. Okay? Now, when you get that, that means you're going to your formula. What is your formula? It's n factorial over n minus r factorial r factorial, which is 2, right? And that equals 300. Okay? So how do you go about working with this one? It's been a long, long, long time since we've done these. What do you do? Expand, good. What would you expand this to? What would the top become? N times n minus 1 times n minus 2 factorial. This 2, what's 2 factorial? 2, can you just go up there, right? Whenever you have things in ratio to each other, so these cancel, so I'd have n times n minus 1 equals 600. Yes. I counted down. Remember, n factorial is the same thing as n. Okay? So then I have n squared minus n minus 600 equals 0. Looking for 2 numbers that add to negative 1 and multiply to negative 600. So you're guessing and testing now anyway, right? So 25 and 24. So n minus 25, n plus 24 equals 0. So my answers are 25 and negative 24. Can't have negative 24 players, so that's crossed out. So there would be 25 players. Okay? So make sure you have a handshake category on your sheet. I want you to have every type of way, the at least. How do you do always at least? At most. Okay, how do you do exactly 2 pairs? How do you do exactly 1 person? If you can identify every kind, you will be able to identify every kind on the... And there's compound questions, okay? So ones that we're going to be learning where there's perms and coms in the same question. Okay? So you really want to know, you really want to keep every type straight. Okay, now, what if I have a circle with 5 points on it? It says, how many triangles can you draw? Okay, so again, this is where you want to have like colored pencils. So you got 1. This would be like, I could go like this, 2, and 3. So there's 3. Then I could do 4, 5, 6. Okay, then I could do like 7. I haven't done this one. 8. Okay, so have I lost you yet? Okay, I can do more. Obviously, I can keep going. But even doing a few, you should start to understand how to do this. What would be the number of triangles that I could do? How would I find that? Is counting the only option? 5, choose 3. You'll get 10. 5 points. I'm choosing 3 every time. You cannot do a triangle without 3 points. Okay, B, how many lines can be drawn on these 5? So they get 1, 2, 3, 4, right? And then, can't do that one again. So 5, 6, 7. Okay, so this one wouldn't count, right? Because it's already been done. All right, and then come here, 8, 9. Okay, and there's only one more unique one left, and it's 10. So I could get 10. How could you have done this without drawing them? 5C2. Okay, so I just want you right now to sketch a pentagon. Everyone know what a pentagon looks like? Okay, it's a Chrysler emblem. Now, how many diagonals can I draw? So right now I want you to draw all the diagonals. So a diagonal is from one point to another. That's our diagonal. We can only go from points, okay? So from point to point, how many diagonals can you draw? How many you get? 5. If it is a star. Now, the question that I want you to come up with is, how many diagonals are in a regular sided polygon? Now, diagonals, and you need to know this, do not count as sides. Okay, so when we did all of the diagonals of the pentagon, including the sides, we had 10. Diagonals, we had just 5. Now, if you were to draw an octagon, that's not, oh, there it is. So if you were to draw an octagon, how many diagonals do you think I could do? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. With me so far here. And then here I could go 11, 12, 13, 14. This is a lot of work. Is there an easier way to do this one? 8, choose 6. Okay, I got a question for you. How would I do it if I'm allowed to include the sides? 8, choose 2. Minus what to get diagonals? Or just minus 8. So that's how you would get the number of diagonals. 8, choose 2, minus 8 sides, right? Because diagonals. So do you see, when you come down to the formula for number of diagonals in a regular-sided polygon is n choose 2 minus n. Two is because you need 2 points to make a line. It takes 2 to tangle. It takes 2 to handshake. It takes 3 to make a triangle. Right? 4 would make not a square, just a quadrilateral. Okay. Now, a polygon has 65 diagonals. Algebraically determine how many sides it has. So then I would go n, c, r minus n equals 65. Now what's one of those that I know? R is 2, because it takes 2 to make a line. 2 points to make a line. Now, when it says algebraically, I always have to go to the formula. So it's n factorial over n minus 2 factorial, 2 factorial minus n equals 65. Now what you want to do is expand the top again. So this will be n times n minus 1 times n minus 2 factorial, and then those will cancel. Okay, so where would I go next? Bring up the 2? I can't bring up the 2 because they're not in ratio to each other. It can only be one fraction equal one fraction to be able to do that. So the best thing to do, or the only thing that what I would recommend, is multiply every term by 2. Okay, so these would cancel. So then I'd be left with n times n minus 1 minus 2n equals 130. Okay, so if you expand that, that's n squared minus 2n, or minus n, sorry, minus n minus 2n minus 130 equals 0. So that is n squared minus 3n minus 130 equals 0. Now, one thing that you will get with all of these is n will be a whole number, because you can't have 6.3 sides, right? So it will be a nice number. What two numbers add to -3, multiply to negative 130? So n minus 13, n plus 10, n equals 13 and -10. Cross out the -10 because you cannot have. So the polygon has 13 sides. Okay, so we're doing 1 to 15. Okay, again, once you get done, you want to get your study sheet, because you just learned a bunch more unique things. Here, just let me just do this, then I'll stop recording.